This is one of the most important figures for the understanding of thyroid hormones and their regulatory mechanisms. The hypothalamus produces thyrotropin-releasing hormone, which stimulates the anterior pituitary gland to produce thyroid-stimulating hormone, which in turn stimulates the thyroid gland to produce thyroid hormones. 85 to 90% of the produced thyroid hormone is in the form of thyroxine or T4, with only 10 to 15% produced in the form of triiodothyronine or T3. From here on, I will refer to them as T4 and T3. They are usually stored in the thyroid follicles in the thyroid gland. Once released, they are heavily bound to proteins, with more than 99.5% of the thyroid hormone bound to plasma proteins like thyroxine-binding globulin, albumin, and transthyretin. The major actions of thyroid hormones are mediated by binding to intracellular receptors of target cells. There are two groups of thyroid hormone receptors: thyroid hormone receptors alpha 1 and alpha 2, thyroid hormone receptors beta 1 and beta 2. They have different tissue distributions, with thyroid receptor alpha 1 being the predominant isoform in the central nervous system, in the heart, in the colon, and in the skeletal muscles. Thyroid hormone receptor beta 2, however, plays a major role in the negative feedback regulation at the level of the hypothalamus and the pituitary gland. To enter the cells, thyroid hormones require specific membrane proteins working as transporters, like monocarboxylase transporter 8. Once entered the cells, thyroid hormones bind to intranuclear receptors, which in turn bind to specific recognition sequences called the TRE or thyroid response elements, which are located in regulatory regions in the thyroid hormone target cells. The thyroid hormones are also regulated at the pre-receptor level by a group of enzymes called deiodinases. Deiodinase 1 mediates the preferred conversion of T4 to T3, whilst deiodinase 2 converts T4 to T3 in the hypothalamus and the pituitary gland. And finally, deiodinase 3, which converts T4 to reverse T3 and T3 to T2, with reverse T3 and T2 being the inactive forms of thyroid hormones.